Hello everyone, develop green buildings and constantly promote green and low-carbon development. Promote harmony between man and nature. Prefabricated buildings actively respond to the National Green Building Development Strategy. In such an era background, we should keep up with the pace of the times. Please follow me to open the door of prefabricated learning. Today, let's learn 1+X assembly building elements, fabrication and installation. Subject 1. Post-simulation process of fabrication of exterior shear wall panel. Today's video is taught by the teacher from Langfang Junk, Construction Industrialization Innovation Research Center.
Hello everybody. In this section, we mainly explain the operation of steel bar binding. We will bind the reinforcements. Then, enter the reinforcements binding area. As we said just now, there are two kinds. One is to click on this die table to move forward. The second method is to click the process prompt. First of all, according to the prompt, let's put the cushion block first. Let's get the cushion block first. You can get more cushion blocks and return them later. Then drag the cushion block to the external panel mold. Horizontal spacing and vertical spacing are within the range of 300 to 800. We enter 500. Click OK. Carry out the reinforcements placement of the external and internal panels. Let's get all the reinforcements first. The reinforcements we get should pass the reinforcement diagram of the external panel. Get the steel panel of the external panel first. We can see the box where the reinforcements are get. It has various forms of reinforcements. There is a difference. There are such straight bars and stirrups. There are such stirrups that have not been thrown out, and there are lacing bars. Then we have to get one reinforcement in turn. Take a look at the one reinforcement of the external panel. It is this kind of reinforcement, that is to say, this kind of simple reinforcement without turning wire. 5 in diameter. Reinforcement grade. We can see the grade of reinforcement here. This symbol represents a cold drawn reinforcement. For cold reinforcement grade, we enter CRB and choose CRB 550. Processing size of reinforcement is 2740. Number of reinforcements is 19. Click Get. Then the to reinforcement is the input 2. Its diameter is 5. The grade is the same. 2640 is the size. The number is 20. Click Get. We switch to the reinforcement diagram of the internal panel to get the reinforcements of the internal panel in turn. We can find that the number of reinforcements in the internal panel is quite large, and combinations of numbers and letters are involved. So we should pay attention to the case of letters. Let's take a look at 3A reinforcement first. 3A reinforcement. It is in this form. We enter 3A. Diameter 16. Grade. Size. This size is the processing dimension of one of its reinforcements in our software. Is to add up all our display sizes. This is 23 plus 2466 plus 290. This 3A reinforcement is 2779. The number is 6. 3B. We enter 3B. Diameter of reinforcement is 6. The grade is also 400. This C means HRB 400 grade 3 reinforcement. Size is 2610. Number is 6. When we input some of these parameters, such as number, grade, size, and diameter, pay attention to them. If you make a mistake, it will prompt you to get again. 3C. Diameter 12. Size 2610. Number is 4. The following is to enter stirrups. The stirrup is a reinforcement with two ends extending outwards. 3D. It is 8 in diameter. The processing size is 116 plus 200 plus 2100 plus 200 plus 116. Then add 200 plus 2100 plus 200 to get 3D is 5232. The number of reinforcements is 13. The following is 3E. Diameter 8. The size is calculated in the same way as just 3D. 3E is 5292. The number of reinforcements is 1. 3F belongs to an internal plastic reinforcement and is also an additional reinforcement. 3F. The diameter is 4332. It is 8 in diameter. The processing size is 4332. On the same principle, the number of reinforcements is 2. There are 3 kinds of lacing left below. Let's enter 3 La. Pay attention to the case of letters. For 3LA, the diameter is 6. Processing size of 3130/30 is 190. Number of reinforcements. The number of reinforcements is not given here, only a spacing is given. We can see from the figure that 3L 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then this is also 13, 14, and 15. That is, 3LA is 15. It's 3LB below. Diameter 6. 184. 26. 3LC. 214. 5. In this way, all our reinforcements will be get. The get reinforcements are in our raw material dragging area. That is to say, our reinforcement layout needs to be dragged into the 3D model for a layout. Then, we switch from processing area to binding area. Let's put the reinforcements of the external panel first. Click No. 1 reinforcement. Drag it into the 3D model and release it. We set the reinforcement parameters in turn. That is, reinforcement placement modes is a parametric setting. Let's take a look at the No. 1 reinforcement first, and click on the reinforcement diagram of the external panel. The vertical reinforcement is No. 1. Then the parameters of reinforcements basically includes the arrangement mode, starting distance, distance from the edge, extending of both ends, and spacing principle. Final distribution, distance spacing, and retraction. Then let's take a look at the arrangement first. From our drop-down box, we can see that there are 4 kinds of arrangements. 1 is none. The second is residual values at both ends. The third is residual value at the end. The fourth is arranged at the left and right ends. Then none generally refers to this kind of single reinforcement, so it is okay to choose No. What does residual values at both ends mean? It refers to, for example, let's take a look at the No. 1 reinforcement. For No. 1 reinforcement, which is evenly arranged in the middle, and then 150. If there are some extra parameters that can't be evenly divided, we need a make even division at both ends. For example, residues of 110 at both ends, respectively, which is a 2x. Then residue at the end means that we have all our parameters remaining to one end. That is, less than 150. We are left to the end. In addition to the vertical residual value here, it goes to the right side. Or, where should our horizontal reinforcement layout be left to us? I want to go to the top. Then the fourth arrangement of left and right ends generally refers to reinforcements arranged at left and right ends. This is easy to understand. So it can be seen from here that the no one reinforcement is with residual values at two ends. What does its starting distance mean? The starting distance is the gap between the first left rebar and the left side of the part at 30 millimeters. Then the same reason. The final distance is the distance between the rightmost reinforcement and the rightmost elements. If it is horizontal reinforcement layout, it is the distance from the first reinforcement at the bottom to the bottom of the elements. Then the terminal refers to the distance between the last reinforcement at the upper end and an upper edge of the elements. Then the starting distance of grade 1 reinforcement. Starting distance is 30. The final distance is also 30. The spacing is 150. Click OK. Here is a confirmation. When we found that there may be parameters problems with the front end, we think there may be something wrong with ourselves. At this time, you can click Modify, which will deduct a small number of points for you. If you think there is no problem with your placement, we will click to confirm. Then put the No to reinforcement. The arrangement of No to reinforcement is also residual values at both ends. Starting distance is 35. The final distance is 30. Let me have a look here. 150 spacing. Click OK. In this way, the reinforcement of our external panel will be laid out. Then we need to bind the reinforcements of the external panel. Get a bundle of tie and a handheld binding machine. Then a layer of reinforcement is bound. We're going to place the reinforcements of the internal panel. So let's drag 3A first. Switch to the internal panel 3A. We must have a macro understanding of the drawings when placing reinforcements. To find 3A quickly. At the same time, because the reinforcement structure of our internal panel is relatively complicated, we should not only combine the front sections and profiles of the reinforcement diagram. 2 profiles and 3 profiles should be combined. For profiles, so let's see where its 3A is first. 3A is reinforcement with sleeve. So we can see from our profiles what 3A belongs to. This is 3A. What are the left and right ends of its layout? It's all 250 plus 50. It's all 300. Then the middle is 300. We set it as the residual value at both ends. Then it is arranged in a left and right plum blossom shape, so the arrangement rule is plum blossom arrangement. Starting distance of reinforcement to the first one on the left is 300, and the final distance is also 300. Distance to edges. Note that the distance to edges here is the distance to the surface of elements. For example, what is the distance of 3A from surface of the elements here? 55. The spacing is 300. Sleeve 16. We need to click OK. Then 3B. For 3B, look at the 3B. It can be seen from the cross-sectional view that 3B corresponds to 3A, so it is arranged in a plum blossom arrangement at the left and right ends. The starting distance is the same as that of 3A. The final distance. Distance, 2 edges. Its distance from edges is relatively small because of the diameter of the reinforcement of 3B. So it is 35 from this edge. Spacing is 300. Confirm it. The following is 3C. Drag. 3C is obviously a reinforcement arranged at the left and right ends. So we have to arrange it at the left and right ends. It is the same arrangement with double layers on top and bottom. Starting distance is 50. Final distance is 50. Distance to edges is 52. Spacing. What is the distance to 3C from it? It's 2000. Stirrup placement of 3D. This is the first reinforcement in 3D. Arrange from top to top. So 3D, we set it in this software in a way that is a residual value at the end. This is also the only residual value at the end. Its starting distance from the second reinforcement to the bottom is 120,300. Final distance. The last reinforcement of 3D is 40 from the top. Change it. Here, this is the first reinforcement in 3D. So what is its starting distance? 120 plus 80 is 200. The final distance is 3D from the edge, so we can't look at section 1. What is the hatch in the section 1? Is 3E. 3E and 3D are not quite the same. From the front view, we can see who hoops 3E and who hoops sleeves. The sleeve is obviously larger than the diameter of reinforcement, so the width of 3 east should be larger. Then we have to look at the section 2. Look at this position. It's a 3D, then for section 2, and its distance from the edges, we can see it is 42. The spacing is 200 from this front view. It's also 200 if both ends are extended. Click OK. Then we put 3 east. For 3 east, we have just said that it is a reinforcement with a hoop sleeve. It's just one. The arrangement mode is directly none. Starting distance is 80. From the section 1, it can be seen that the distance from the edge is 27. Both ends extend 200. Confirm it. 3F. 3F belongs to an additional reinforcement, so it has only 2 bars. There are only 2 to the top of the sleeve. The starting distance is generally 300. This one and this one start at 300. In the end, this reinforcement is 100 from the top. That is, the distance from it to it is 100. 100 plus 2000 plus 40. That is, its final distance is 2140. (3E) and 3D have the same distance from the edge, both of which are 42. The spacing can be seen from the front view that the spacing is 200. Retract at both ends. We need to calculate the retraction according to the reinforcement table at this time. 3F. For 3F, its distance is 2050. In fact, the width of one of our internal panels in this direction is 2100, so the retraction is 25. Then our main reinforcements are laid out. What we're going to put next is one of our lacing bars. Put the lacing. Put 3 LA first. 3 LA's lacing. we can see LA is in this position. That is the intersection of the third vertical reinforcement and the first horizontal reinforcement. Then there is one for every other vertical reinforcement here, and then there is one for the adjacent reinforcement. There is one every 2 reinforcements between the top and bottom, and then it goes all the way down. It's just that when it comes to the last reinforcement, it's a reinforcement at intervals. One this reinforcement and one additional reinforcement. So according to this rule, we can place 3 LA. We must drag the lacing when placing it. Drag it to our pre-installed position and release it. At this time, if the lacing is placed correctly, it will show red. If it is misplaced, the lacing will disappear. We put lacing in turn. Then put 1 or 2 columns of La. La is placed. Next LB is placed. That is, the margin on both sides of LB goes all the way to that position. It's up to 3 LB. There is the same LB on the right side, so let's put LB in turn. LB placement is completed. Then we put the LC according to the drawing. So this is all you'll see. Only the lacing of the sleeve, near the sleeve. It's in the sleeve. It's on the left side of the sleeve. According to this rule, we need to place LC The reinforcements of one of our internal panels are laid out. We need to bind the reinforcements at the second layer. The embedded parts should be placed. Let's take a look at the template diagram first. Then we can get from the drawings. In the template, we can get our embedded parts, mainly including casing. There are 8 casings. It's all casing. 2 hanging nails. There are 4 inner threads in total. Then 1 line box, a pair of conduits. Then there is a small square slot reserved in this place. Then we have to get our embedded parts first. 1 line box. 2 hanging nails. 4 inner nuts. 8 PVC pipes. 1 square slot. According to here, we can see that the embedded parts we can get are in this position. Let's put the external panel. The embedded parts of the external panel are mainly conduits. PVC casing. There's one less conduit. Let's enter another conduit and get another conduit. We can just get one. Then the PVC sleeve is mainly on the external panel, because it needs to be embedded and fixed on the external panel first. And then concrete is poured. Then we're going to place the casing first. According to the drawing, we can see how far the sleeve is from the left side. The distance to the left is 270. 100 plus 2000 plus 40. 290 plus 200 equals 490. What is the distance from the bottom? The distance from the bottom is 270. It's from this end, because this is the innermost side of our fixed end mold. So the distance from this end is 270. In turn, the above data is the same as the left data. It's only 680 from the bottom side. Then an addition is performed in turn. Then the sleeve on the right side is also from the left and the bottom. What is the distance to the left side? It's equal to 2680 minus. Subtract 290 here and subtract 200. That is how much? That is 2190. Then the distance from the bottom is also 270. Then this one is 270 plus 680. So it's such a pattern. Then I'm going to lay out our PVC sleeves next. I'm going to make a quick arrangement next. Let's arrange this one 270 first. It is 490 from the left. The distance from the bottom is 270. Then 490 and 950. 1690. 2440. The right sleeve needs to be placed below. 270. 'The sleeve of our external panel is placed. We're going to put the internal panel. Place hanging nails from top to bottom. The left and bottom of the nail spacing depends on this diagram. This distance from the left is 450. If the distance is from the bottom, it is from this side of the internal panel, because this side will be in contact with our mold table. So it's 65, 450 to the left, and 65 to the bottom. Then the distance from the right end to the left is 1650, 65. Then put the inner thread. The inner thread is also the same distance from the left to the bottom. It's just that the distance from the left is the edge length of the internal panel. For example, this inner thread is 350 to the left. What is its distance from the bottom? Its distance is 1390 plus 550 from this position. 1390 plus 550, which is in 1940. Such a pattern. So let's arrange these 4 inner threads in turn. So let's take a look at the first inner thread. We will arrange it from bottom to top. For inner thread, we are from bottom to top. the first 350,550. It is arranged 350 in the lower left corner. Because it's the same distance from it, and it's all in a straight line. And then 550 if you go down. It can be seen here that it is 550. Arrange the second 350, 1940, in turn. Then arrange 1750, 550 at the right end. Then we're going to put the line box. The spacing of the line box is 750 to the left and 750 to the bottom. Then place the conduit. We set the position of the conduit and the line box to be the same. Square groove. Square groove, we can see from the drawings. If it is 747 from the left to the bottom, we will write it as 0. Then we're going to put the fixture of the embedded parts. Click the tool gallery. Click the fixing frame of the embedded parts, and then fix the embedded parts. Then we have to plug it. Get plugging materials. Get a packet. Plug it. In this way, one of our steel binding operations will be completed.
以上就是本小节知识点的讲解。预祝大家在学习装配式混凝土建筑施工课程的过程中，拥有一个快乐的学习旅程。